Okay. Um, let's see what's next on my list. I just woke up, by the way. I was actually leaning back in my chair, with my foot up with this nice little tiny ottoman I got from Amazon for like 25 bucks. It's cheap as hell, but hey, it works. Um, I mean, cheap as hell. It's like, it's all folded. You got to unfold it, and then you put like this flat piece of cardboard at the bottom of it to keep the sides from caving in. And then you put your little cushion on the top. And yo, it is the best thing I've ever had to put my feet up on. Okay, and it's not that high. It's not like the height of a regular ottoman for like a couch, but hey, man, I was watching a TV show on Netflix. I leaned back, put my feet up, and yo, I can't. Yo, if I fall asleep like that, that tells you how comfortable a chair I got. So, hey, I'm not bitching, but nonetheless, I just woke up. And I was like, oh my god, it's almost 7 o'clock. But nonetheless, VPNs. Okay, so what I told you about the GNS3 thing, creating tunnels in GNS3 and so on and so on. Okay, um, those tunnels. Okay, as we're going from site to site. Okay, and as we are encrypting those tunnels, that's a virtual private network in its own. Okay, think about it. You got virtual links. Okay, it's virtual. Okay, it's sitting over top. You know, there's an underlay that's actually moving that traffic from one area to the other. Now, an overlay and an underlay. An underlay is okay, plain and simple. The internet. We built the tunnels over the internet. The internet is our infrastructure that is our underlay. Okay, and our overlay is the actual tunnels that we went over it. So we literally could create many tunnels and have our own internet on top of the internet. Okay, and have our own private network. Okay, that's a VPN. Okay, all right. We think of VPNs as a way of logging in, okay, from a remote location, okay? All right, and it's not just that. So what happens when you actually are logging in, okay, to a company or to a site, okay, via a VPN? Well, first of all, okay, tunnels are being created. Okay, that's the whole purpose of it. Okay, and in that tunnel, once the first tunnel is created, we are exchanging information back and forth to build technically the real tunnel, the real VPN tunnel that we need to, send traffic across of. Now, hang on for 1 second. Okay, all right. So, now I'm not going to say I agree with this list. Okay, all right. But this list was created from reading about VPNs at one time, and I just added these to the list. Okay, but I can't tell you what. All right, so just because I don't agree with it doesn't mean that I would never use the terminology about defining them as a VPN, or nor would I deny that it is a VPN in itself. But knowing what the terms mean, if you're sitting in a conference call, okay, with your teammates and saying, "Hey, why don't we just make a VPN between the switches with Q and Q?" Okay, then you are going to most likely make them think about a remote VPN or a site-to-site VPN. Okay, because that's really what the term is recognized as when us engineers and IT folks, okay, because it goes hand in hand, talks about VPNs. All right. So, I call Q&Q Q&Q. I don't call it a VPN technology. Okay. Frame relay, I call it frame relay. Okay. I'm not going to say, I'm not going to say, hey, um, why don't we just create a frame relay VPN? It's just something I'm not going to say. Okay. All right. With MPLS, okay, I'm going to say let's create an MPLS layer 3 VPN. Okay. That has validity because that is a configuration and technology that exists within MPLS. Okay, all right, but I think the documentation was talking about MPLS because the labeling aspects is a tunnel in itself, and and hey, don't take that for uh, uh, boarded in stone, if that word even exists. The first one I said. I'm not saying that's written in stone. That's what I read. I'm just saying I did not put VPN layer 3 VPNs, so I'm assuming that's why I wrote it up there. Okay, but again, this is years ago, so all right, and I'm not going through and prepping and making sure all my information up here is correct. All right, now a PVC. Okay, a PVC is something that's used with frame relay. Okay, now we're not going to learn frame relay, even though it is another one of my favorite topics to teach and educate, because frame relay can trip you up in some aspects. But the reason why we're not learning it is because frame relay, and don't get me wrong, do not get me wrong, and do not get it twisted. Frame relay still exists today and is still out there. Okay, however, it is considered a legacy technology. So you're not going to see it as much as you would have. Like, in my career path, I saw a lot at one particular company. Okay, and I haven't seen it since. Okay, but don't get it twisted. You can still call an ISP and say, "Hey, I want frame relay circuits." Okay, and who's going to use those? Hey, financial people, like banks. Okay, there's no way in hell I'm going to send the MPLS circuit to each one of my branches. Okay, I got how many branches? All right, now to my headquarters, yeah. Okay, let's bring in an OC or a Sonic or a T3 line. Okay, but to my branches, no, they're gonna get frame relay at best, okay, or maybe just a T1 line, okay, and the hell with it, okay, all right. Now, hell, we might even go back down to serial links and create multi links in order for us to have a bigger speed, okay? Because why spend the money if you don't have to? And because branches are not the traffic that they're sending back, really that's important is ATM information and communicating with the actual headquarters. And that traffic doesn't need to be high speed. It doesn't mean, a frame relay circuit that still has the reliability, okay, because the SLA you're getting is anywhere from 5 nines to maybe, maybe 9 nines, okay? If you don't know what 5 nines is, take 5 nines 5 times, okay? I'm literally the digit, the number 9, write it out 5 times, okay? And from the left hand side to the right, move in 2 decimal points. That's 99.999%. That's the 5 nines, okay? All right, and that is your service level agreement that you're going to get from your service provider. Okay, so it's so frame relay is still out there. Okay, so if I took the time to teach it to you, okay, you might thank me later for having a sales staff, because I'm gonna tell you, in reality, this is what's going to happen. If you're working at a company and it has frame relay, you're going to be the only person that knows it. Okay, that was the case when I was actually working in a knock, and that was that was over 10 years ago. Okay, All right, and notice I said over 10 years ago. I can't tell you how many years exactly. Okay, so with frame relay, a PVC is a private virtual circuit. I don't even think private is the correct word. But nonetheless, let's look it up real quick. Oh, what am I doing? I don't even know why I'm doing that, but nonetheless, frame relay. Ah, PVC. Okay, you're not telling me what. Oh, here it is. Permanent. I'm sorry, permanent virtual circuit. I was reading past the actual parentheses sort of before it. Okay, so it is permanent, and I was sitting thinking in my head too: is it permanent or is it private? Okay, so PVCs are considered VPNs too because they're logical connections. Okay, I don't see it as a VPN technology, but doesn't mean that it's not. Okay, and in the scheme of things, okay, calling it a PVC, all right, um, calling it a PVC or calling it a VPN, it's kind of semantics. Okay, and remember when I was talking about placing your argument? Okay, it's the same thing with choosing words. Okay, use words that you know people are going to understand what you're talking about. Okay, don't try to always be 100% accurate with the words that you're using. Well, exactly. Well, technically, PVCs are VPNs, and we shouldn't be calling them PVCs. We should be calling them. Nobody has time for that crap. Okay, either I get what you're talking about or not. All right, and every time you say VPN, I'm only thinking of site to site, land to land, remote access because guys, that's just that's going to be the norm in IT in general. Okay, in order for someone to think of it in a different way, like the average IT person, they would have to know networking to a certain level, and that's not going to be the case. Okay, and when you talk about MPLS, they know what MPLS is, and they also know MPLS has layer 3 MPLS VPN technology as a service that is sold to you by your ISP. Okay? Make sense? All right? So now, GRE, we already talked about those. IPsec, we haven't talked about that yet. Okay? And IPsec works at layer 3, point-to-point tunnels. Okay, all right, so let's talk about VPNs that we would normally think of when we're talking about VPNs in the industry. Remote access. Remote access is the concept of using a client on your desktop, okay, or a website using SSL or whatever methods that you're going to be using for connecting to the site that you want to get to. Okay. There is a private IP address scheme that's inside the network that you would normally get if you were physically at the site. Okay. Let's say it's a 192.168.1.0 network. Okay. But when you remote in, okay, you are going to put the destination IP address that you want to get to, which is going to be the site's public IP address given to them by their ISP, okay? And then something on the other end that you're trying to connect to is going to receive that traffic at a particular request, and it will start negotiating these tunnels and negotiating the IPsec aspect of it. Okay, so your information is encrypted, secured, and verified. All right, from end to end. Okay, meaning that when I send a traffic, okay, all right, that traffic has to be the same traffic as it left, and as it arrived. It needs to be protected, okay, by authentication, and okay, it needs to be encrypted. Okay, so that is the purpose of the remote access. Now, when you finally are approved with your authentication and able to get into the site, you're not going to get a IP address off of a different IP address scheme. You're going to get a VPN IP address for that site. And that could be 192.168.15. Whatever. Okay? All right? So, anytime I see a user trying to access something with a source IP address of a 192.168.15, I know this is a remote user coming in via the client or web page. Okay? All right? Anywhere I want to set it up. Okay? Now, that's remote access. Anywhere in the world, okay, I can actually access my company's network, okay, or my network, so I can communicate with them, okay. Now, Bunny and I created tunnels between our Cisco routers, okay, all right, and we actually encrypted those tunnels, okay, and use EIGRP to share our subnets for our internal private LANs, right? Our private IP addresses. Okay. Then I had my Cisco call manager. Okay. All right, guys, I could not get that. I could not think of that damn name yesterday to save my life. Cisco call manager, and he used an IP address. I'm sorry. He used a VoIP phone, Cisco VoIP phone, and I added his MAC address to my call manager. Okay. Now, because of our tunnels going back and forth and sharing routes, he could ping. I could ping his phone, and then I could add his phone to my call manager. And all he had to do was pick up his phone and dial 4 digits to make my phone ring at my house. Okay. That's the power of tunnels. They're awesome. Okay. All right. Understand, when you're doing VPNs and doing tunnels, what you are doing is you're extending your network to another location and making it seem like that network is on your same LAN. Okay? Giving you the ability to ping that address, one private IP address to another private IP address, and you're doing this across a public network, which is the internet. Okay? Now, a site-to-site VPN is what it says. Okay? You have a router sitting at site A and a router sitting at site B, and you're going to make a physical VPN connection, okay, building tunnels across the site that most likely is going to be up the entire time, okay, and, all right, and that traffic is also encrypted, all right, and all the traffic that leaves that interface that is assigned to that tunnel, okay, and there is a tunnel going from site A to site B, but that's it. Okay, so anything that leaves that interface is going to go to the other end of that tunnel. Okay, so you've made kind of like this permanent, not like a PVC, but a permanent connection, even though it is a permanent virtual connection, but it's not, considered a PVC because PVC is a frame relay terminology. All right, not saying that you could not call it that, but that site to site, okay, that is your only connection. Okay, all right. Now, anytime you go to send into traffic out interface FA00, it's going to hit the other side of that tunnel, which is router 2's FA00. Okay, if you want to go somewhere else, you can't. Okay, you can't. All right, that's a site-to-site VPN. Your sites are connected across the public network, okay, with an encrypted tunnel, okay, and that is your way to get your traffic from point A to point B. Why do this? Well, here's the thing. It's our tunnel. It belongs to us. And I don't have to pay the ISP for any other services. Why should I? Because I got a layer 3 connection going from point A to point B where I can send classified traffic without worrying about anyone sniffing the traffic. It's private. I'm using the public internet. Okay? That is not encrypted. Okay? That is Wild Wild West, every man for himself. Okay? And build a secure link between two sites. And it didn't cost me a dime. Okay? Alright? If I want to say it cost me anything, is the price of my internet connection. That's it. Okay? If I wanted to use VPN, okay, MPLS VPN or Friend Relay, that's a service, okay, that the ISP will provide to you, okay, and it costs. It costs you money, okay, but site to site is free. It's just configuring it yourself, and now you have a connection from site to site, okay. Now, can I do it like a hub and spoke type scenario where I have a headquarters, okay, that has a site-to-site connection going to site 1, another one going to site 2, because at some point that means now my interface, if my interface is set onto a particular site, does that mean I have to have 3 separate sites? Okay? Alright, on the hub, can I change it to like a multi-point? Okay? And I'm not answering that question. You can do your own research on that. Okay? Because in all honesty, if you wanted to do something that way, I would recommend my next favorite topic to talk about, DMVPN. Okay? Alright? Where you can change your tunnel interfaces because DMVPN uses tunnels. You can encrypt them as well. And you can actually use point-to-point. Point to multi-point. Okay? And not to mention the fact that you can actually have virtual tunnels created from spoke to spoke, not having to transit the hub. Alright? I'm a huge fan of DMVPN, by the way. Okay, so now. Okay. So, those are your 3 types of VPNs. The one that I don't have listed here is a LAN-to-LAN VPN. Now, a LAN-to-LAN VPN, okay, now keep in mind, a site-to-site VPN can be utilized via firewalls, ASAs, firepower, okay, or routers, okay, where a LAN-to-LAN VPN has to be ASA or firepower, okay? I don't think you can do those on routers, and if you can, I don't know how to do it, but you might be able to do it on ASRs. All right, but I don't know. Okay, so now, okay, and if you don't know what an ASR is, those are kind of like your next generation WAN routers. Okay, all right, where you could do some pretty cool things with those things. I love them. All right, matter of fact, I got one here. I just got from my buddy. It's kind of a big one too, but I need to get another one so I can practice the services. All right, so LAN-to-LAN VPN is this. Okay, on one side, because you got to configure both sides, right? But on one side, I'm going to say anything that's coming from 192.168.1.0 going to 192.168 to 2.0, all right, send it across the tunnel. Now, keep in mind, remember I said the site to site is like always up. Whatever goes into that out the interface goes into the tunnel and outside the other. Where a LAN to LAN VPN is only going to establish a tunnel during the time traffic is coming from the 1.0 network to the 2.0 network. Now keep in mind, site 1 has the 1.0 network on its side of the house. Where router 2, okay, where you want to build your LAN to LAN, meaning site to site, right? It's not site to site, but they're 2 different sites, and it's a LAN to LAN because site 1 LAN's going to site 2's LAN, all right? we're going to make the tunnel when the traffic is being sourced and destined for the networks that you choose. Then, once the router sees that traffic, source and destination matching, it'll build a tunnel over to the other one, to the other site, to the other router. Okay, they'll negotiate the tunnel and they'll forward that traffic. Okay, via layer 2. Okay, all right. Now, why do we say layer 2? Well, because we're going from LAN to LAN. Okay, all right. Technically, it's LAN to LAN. All right, meaning that we can move traffic from one side, on my side, from a subnet and a VLAN, okay, over to another subnet and VLAN onto the other site, okay, all right. That's the best way for me to explain it, okay, all right. You can do your own research to figure out why they call it layer 2, okay. I call them LAN to LAN VPNs, all right. I don't call them layer 2 VPNs, all right, because to me a layer 2 VPN, okay, is something like XVLAN, right? Or VXLAN, however you say it. Okay, all right. That gives you the ability to actually transport layer 2 traffic over a layer 3 platform. Now, remember what I said. Everything in networking can be broken. Okay, and when you're transferring layer 2 traffic over a layer 3 link, guys, that's just magic. Okay, it will always be magic to me, but with headers and encapsulation, anything's possible. And every rule you have with networking or TCP/IP can be broken. Okay, all right. Now, when I say every rule, whatever we can't break today, I'm assuming that we'll be able to figure out sometimes in the next year. Okay, just like science, we are always growing with technology. Okay, all right. So some rules you don't want to break, some rules, bam. Okay, the technology comes out, all right, and you're just like, why the hell do I even need this? And then you realize, like, wow, this is pretty damn cool. Okay, so, all right. So now, what are the benefits of a site-to-site VPN from router to router or ASA to ASA? Oh, by the way, I don't know if I said this, but the LAN-to-LAN VPNs, I think I did say it, but I'm going to say it again, has to be an ASA. Yeah, I did say it again because I was talking about how I don't think routers can do that besides the ASR. So, nonetheless, okay, so I'll move on. Now, with these features, remote access, site-to-site, LAN-to-LAN VPNs. This can be done anywhere in the world. Okay? Alright? With DMVPN, okay, which is another method, but a different type of configuration, but it is still a VPN. As a matter of fact, we need to add these in case I ever LAN to LAN DMVPN. Okay. They all can be encrypted. They all can be authenticated. Okay. Anti-data corruption is really just making sure the traffic hasn't changed. Okay. From source to destination. Meaning that someone didn't hack it, decrypt it, and opened up the data and put extra bits in that data and send it off for a hacking attempt. Okay, all right. And be honest, if someone has gone through that much trouble for traffic that just randomly they just happen to catch, you gotta give them some type of props. All right, I'm talking, especially with the decryption part. Now, okay, confidentiality, meaning that's no one else can see it. That's the encryption part. Okay, and use crypto commands, which we'll cover off once we get our last step back up. Okay, all right. So that's pretty much it, guys. VPN in a nutshell. Okay. Now we are traveling down foreign land here from my perspective, because every time I would talk about theory, I would go right into a lab. And right now, because of our situation, which is was unexpected, we're going to be going back to these topics to do the labs. Okay, so it is what it is. Hey, as long as I keep feeding out information, you know, I'm good with it. So you guys ain't sitting there from weeks and weeks and weeks waiting on me. Nonetheless, be strong, be determined, be Cisco.